Hello, sir. Good evening. I would like to start the presentation by saying that we are using recommender systems in our daily lives a lot. Like we are using Instagram, shopping on Amazon, or watching movies on Netflix. Algorithms are quietly predicting our every next move. For years, the gold standard for these systems has been collaborating filtering, which has been using our data to find our likings and dislikings. And but there is a major bottleneck. Traditional models treat items as meaningless numbers. They do not know that the Terminator and the Matrix share the semantic themes of sci-fi and artificial intelligence. But what if we could use the semantic power of large language models like Quen, Llama, GPT, any of those models to understand the text of the history? In this video, we are breaking down to a comprehensive evaluation of zero-shot, fine-tuned, and two-stage LLM pipelines tested on MovieLens 100K dataset. We will look at what works, what fails, and how this fits into the cutting-edge landscape of AI recommendation. So the dataset we are encountering in this is MovieLens 100K dataset with 100,000 ratings from 943 users on 1,682 movies. And five-star ratings has been flipped into a binary classification. That is, more than 3 stars is liked, and less than 3 stars is disliked. Uh, Before we can ask AI to recommend a movie, we have to translate user behavior into the language AI understands. We started with movie lens and binarized the data. To rigorously test our models, we used leave one out protocol, and uh, we take a user's chronological watch history and separate the very last movie they liked. This becomes a target positive item. We then hide the true positive movie in a pool of 99 randomly sampled negative items. That is dislike movies, movies the user has never interacted with. The LLM is given user's history and score all 100 candidates. The ultimate goal, to rank the true positive movie as close to rank number one as possible. So the paper we are following for this approach is the Tolerate framework and logic extraction. Terminal window types out a prompt dynamically. Your movie recommendation assistant like Terminator. The like movies can be Terminator, Speed, Godfather. I'm just giving here examples. Given this history, will the user enjoy Top Gun? That is the question we are going to ask. The Top Gun is going to be the movie we are asking in the prompt. Uh, An LLM will output a distribution probability distribution instead of generating test. A Gauss 2 points probability of yes, let's say 8.5, 0.85 for the Top Gun movie. To get the LLM to actually generate these ranks, the Tolerec we have adopted the Tolerec methodology. Tolerec uh, treats the recommendations as an instruction tuning problem. Instead of asking the model an open-ended question like what should this user watch, we construct a highly structured prompt containing up to 10 recently liked movies and 5 disliked movies. And we then ask the binary question, will the user enjoy this target movie? Yes or no? As simple as that. So, uh, uh, while asking an LLM to generate text for thousands of users and items is incredibly slow, instead of auto-regressive generation, we perform a single forward pass and extract the raw log probabilities uh, by applying a binary softmax. We get a precise probability score that we can use to rank the 100 candidate items from best to worst. So for first experiment, we went with surprising power of zero shot. That is, we had used Quen model with zero shot inference. Like we had not given it examples beforehand, and uh, we started with uh, 4-bit quantization of those models, and the results were remarkable for these models. I'll be sure the results as well. Uh, when we had used the Quell model, zero shot, we achieved the hit rate of 42% and 56% respectively when we were marking with 10 users and 20 users. This is for Quen model, and the NDCG was 21% and 25%. And when we used Gamma model for the same thing, we got these results as you can see. And then we went to fine tuning after that. And here's the implementation formula of our approach. That is the locket we had taken. Seeing the zero-shot success, we assumed that fine-tuning model using LoRa would push the performance even higher. However, we encountered a classic machine learning trap. When we fine-tuned Qwen 3 model to a constrained subset of 50 users, roughly 1700 examples performance plummeted to just 10% hit rate. The model severely output the uh, training to the tiny training set, but achieved some success with lot of tuning. But they demonstrated that you need adequate recommendation data and a proper instruction tuning phase to maintain the model's generation capabilities. So we went with the final solution that we need to organize our data better to use some fine tuning. So we went with the two-stage pipeline. That is the ALS plus LLM re-ranking, and how we went with it. So let me explain. Uh, this is our code for that approach, and okay. Uh, LLMs actually possess, uh, let's say, so this is the code, and this had been done by my partner, the final code. So these are the LoRa adapter settings, and we had used rank 8, and we took alpha value 16. This can be taken 32 as well, but we went with 16, and we kept the dropout minimum to a 0.05, and we ran it in causal state. And we ran only one epoch because it was taking too much time to run. And the sequence length can be reduced as well, but we went with this. And okay, and the final results, let's get to that. Got a result of uh, the hit rate was 70.31 for the re-ranking stuff, and NTCG was 52%. And when we were taking with just ALS, we were at 67%, and NTCG was at 48%. So that was the development we had. And let me show you the other models as well. This was the Gamma model code, and here it is. Let me scroll to the bottom to get to the results. Here's the results, and the other model that is on my system as well. Here is it. Here's the results, and thank you.